So, hello, my dear friends. Let's continue the next session now. So, if you see in the previous session, we have started with central tendency and we have completed mean, we have completed mode and partition values we have seen in individual data, right? So, today our target will be to complete the entire central tendency and to start with the dispersion and discuss few points in dispersion. If time permits, we'll do the homework sums as well in today's session. Okay. Now, first, let us revise all things what we have done till now. First, we understood what is central tendency. In central tendency, we are trying to locate one observation which is used to judge the entire data. That observation which judges the entire data is called a central tendency value. I said you it is also called as measures of averages or average of first order. Now, why it is called as average of first order? If you see in statistics, there is an order of study what we need to follow. First, we need to study central tendency, next dispersion, next skewness, next kurtosis. Central tendency, dispersion, skewness, and kurtosis. That's the reason central tendency is called as first order, dispersion second order, skewness third order, and kurtosis fourth order. Now, how many types of central tendencies we have? Three types: mean, partition values, and mode. Mode is also called as norm. This mean, it is a part of algebraic measure. This partition values and mode, they are a part of positional values. So I hope till here it was simple. Next, mean we have seen three types: AM, GM, and HM. Now let's have a quick revision of all these things. Arithmetic mean. What is arithmetic mean? Sum of observations divided by number of observations. What are the formulas? Summation of x by n in case of individual data. Summation of fx by summation of f in case of discrete data. Summation of m into f divided by summation of f in case of continuous data. We have deviation formulas also, but those deviation formulas are useless. Just remember that in deviation formulas, mid value will be the assumed mean. That is a plus summation of d divided by n will be the formula. Next, after this, if you see, I said you that combined arithmetic mean formula n1 x1 bar plus n2 x2 bar by n1 plus n2. If more than two sets of data is there, accordingly the formula will change. Next, after combined arithmetic mean, we have corrected arithmetic mean. Old arithmetic mean into old observations minus incorrect value plus correct value by new observations. Next, we have weighted arithmetic mean. Summation of weights into x by summation of weights. I said you if all observations are given equal weights, then simple arithmetic mean and weighted arithmetic mean will remain same. Next, if mean, partition values, mode, entire central tendency, I said you it is affected by scale and origin, right? Next, what do you mean by scale, multiplication, and division? What do you mean by origin, addition, and subtraction, right? Next, I said you mean gives importance to highest observation. It is affected by extreme observations. Next, sum of deviations from arithmetic mean is 0. Here, one point is pending. Sum of square deviations from arithmetic mean is minimum. This point is pending. We'll do it today. Next, after this, we have looked into geometric mean, nth root of product of observations. Individual data formula x1 into x2 into x3 so on till xn whole power 1 by sum whole power 1 by n. Next, discrete data x1 power f1 into x2 power f2 so on till xn power fn whole power 1 by summation of f. Next, after this we have continuous data. Continuous data will be m1 power f1 into m2 power f2 so on till mn power fn whole power 1 by summation of f. So this were individual, discrete, and continuous. Next, I said you if one observation is 0, GM is 0. If one observation is negative, unfortunately, GM cannot be calculated. Weighted GM you can calculate, combined GM you can calculate. Formulas are not that important, just you need to remember them. Next, I said you that GM is used for index numbers, rates, ratios, and percentages. Next, after this, I said you that GM is used when there's a constant increase or constant decrease, right? Next, I said you if all observations are same, AM, GM, HM is same. That is common property in all these three things. Next, after this, I said you like arithmetic mean GM is also affected by scale and origin. Next, GM of xy will be equal to GM of x into GM of y. GM of x by y will be GM of x whole divided by GM of y. So these were the things we have done with respect to geometric mean. Then we went to harmonic mean. I said you the reciprocal of arithmetic mean of reciprocal of observations is called as harmonic mean, right? Formula is n divided by 1 by x1 plus 1 by x2 so on till 1 by xn. How will you do in the calculator? First you will do denominator. 1 by x1 m plus 1 by x2 m plus 1 by x3 m plus so on. Numerator divided by MRC equals to. Directly you can Okay. Next, after this, I said you harmonic mean if one observation is zero, unfortunately, harmonic mean is undefined. One observation is negative, yes, I said you it is defined. Next, I said you AM gives importance to highest, GM to all, HM to lowest, right? Next, where you will be using HM to average, speed, distance, and time. This is very important with respect to HM, right? Next, combined HM can be calculated, weighted HM can be calculated, right? Next, I said you relationship between AM, GM, HM. GM square is equals to AM into HM. One more relationship will be if AM and GM will be given, those two numbers are AM plus or minus root of AM square minus GM square. So this was all regarding mean. Next, I said you mode. Mode means most repeated observation, right? Now, it can be either unimodal, bimodal, trimodal, or multimodal. Where you will be using this in case of fashion items and zoology. Yesterday in homework questions, I have given you one fashion item and I said you calculate the best central tendency value. Then the answer is mode. Okay. Next, after this, I said you how to calculate mode. Individual discrete data was simple. Continuous data, first you will calculate model class, then you will apply the formula L plus F1 minus F0 divided by 2F1 minus F0 minus F2 into class interval. This is what we have done. Next, after this, we came to partition values. What partition values does? They simply go ahead and they divide the data. That's the main purpose of partition values. Next, I said you that you're having 4 partition values: median, quartile, decile, percentile. Median 2 parts, quartile 4 parts, decile 10 parts, percentile 100 parts. You will have 1 median, 3 quartiles, 10 deciles, 99%. Be careful. So how will you do in case of individual data? First, what we'll be doing, we'll arrange the data in ascending order. Then you will apply the formula G into n plus 1 by 4, n plus 1 by 10, n plus 1 by 100. Accordingly, for quartile, decile, percentile. Will this give you the answer? Unfortunately, no, it will not give you the answer. What it will do, it will just give you the location. You'll go ahead and you'll identify the location, which after identifying the location, you will go ahead and you will get the answer. So this is what we have discussed in last session. Today, we'll complete central tendency chapter. Half of this question also will come. Okay. I hope there is no issue till here. Shall we proceed? Homework sums, don't worry, we'll discuss it. Once let the whole chapter get completed, we'll discuss it. Now, so I hope it's fine for you people to compute partition values for individual data. We have seen median, we have seen quartile, decile, percentile. Now let's proceed further, my dear friends. Now, Q2 will be equals to D5 is equals to P50 is equals to median. This is one relationship what you need to know. Sir, why like that, sir? Simple, let me teach you here. In this example, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 observation sample. Let me take one more example. I'm having 10, 15, 30, 65, and 70. What is median here? Median is equals to mid value 30. What is quartile 2? J into n plus 1 by 4. 2 into 5 plus 1 by 4. 2 into 6 by 4. That is equals to third observation, which is equals to 30. In the same way, decile 5. J into n plus 1 by 10. 5 into 5 plus 1 by 10. 5 into 6 by 10, which is equals to third observation. What is third observation? 30. So can you see here, my dear friends? Median, decile 5, and quartile 2, all the three are 30 itself. Even if you calculate percentile 50 also, you will get the answer as 30 itself. Okay. That is the reason I said you median is equals to second quartile is equals to fifth decile is equals to percentile 50. Okay. I hope this relationship is clear. Next. In the same way, quartile 1 will be equals to percentile 25 because quartile divides the data into 4 parts, right? See here, quartile divides the data into 4 parts. If I am saying whole data is 100%, then what each part will be? Obviously, sir, 25% will be each part. So each quartile covers 25% of data. Okay. That is the reason quartile 1 and P25 will remain same. Quartile 2 and P50 will remain same. Quartile 3 and P75 will remain same. Okay. Next, these three. Obviously, in quartile 1, quartile 2, quartile 3, which is greater, my dear friends? Quartile 3 will only be greater because you are arranging the data in ascending order, right? So obviously, quartile 3 only will be greater. The same way, P1, P2, P3, so on till P99, which will be greater? P99 will be greater. In case of deciles, D1, D2, D3, which is greater? D9 is greater. Okay. So I hope this remembering points is clear. Now, this one, I'll come back to this point later. Give me some time, I'll come back to this. Now, my dear friends, we understood how to calculate quartiles. This is octile 3, you don't have in your syllabus. Okay. This quartile, percentile, this is octile, this is. CMA people have that, but CA people don't have that in syllabus. Now, my dear friends, we have seen partition values. We have seen how to calculate partition values in case of individual data. Now, next what we have? Obviously, sir, you have discrete data and continuous data. So first what I'll do continuous data. I'll solve two sums from continuous data. Later, I'll give you one sum. You think and solve and tell me the answer. Let me open the ICA material. Sure, let's solve. Now in continuous data, how will you solve, my dear friends? First step, what you'll do is that you'll go ahead and you'll calculate LCF. We already know LCF, how to calculate. What is LCF? Less than cumulative frequency. First step is you'll calculate less than cumulative frequency. Second step is you'll either calculate n by 2 or jn by 4 or jn by 10 or jn by 100. In case of median, we'll calculate n by 2. In case of quartile, jn by 4. In case of decile, jn by 10. In case of percentile, jn by 100. See, numerator is same. What changes is denominator. Now, this step 2, what is there? You locate the step 2 value in LCF. Once you locate the step 2 value in LCF, you will get the partition value class. After getting partition value class, you will apply step 4. If you've seen step 4, my dear friends, only this part of formula changes. Balance entire formula remains same. L is lower class boundary. CF is cumulative frequency of previous class. F is frequency of same class. CI is class interval. You need to mug up the formula. There is no logic behind this formula. These are interpolation formulas. We call them as interpolation formulas in statistics. Okay. So just go ahead and mug up this formulas. Only that part of formula is different. Balance entire formula is same. So I hope it is easy for you to mug up. Only this n by 2, jn by 4, jn by 10 and jn by 100 is different. See, this step 2 itself you have applied here. Okay. So no confusion. Now, so this is all regarding continuous data. Let me explain you with the help of sums. It will be more clear. Example. Find quartile 2 and percentile 65 and quartile 3. Find percentile 65 and quartile 3. Let us do. Yes, sir. Let us do. Now, observations are given less than 10, 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59. Next, frequency is given 5, 18, 38, 20, 9, and 2. So observations are given, frequency are given. We are supposed to calculate percentile 65, quartile 3. So first I calculate quartile 3. Quartile 3. Now, my dear friends, before solving, can you tell me, is it inclusive or exclusive data? Obviously, sir, it is an inclusive data. And I'll give you one more name also. This is called as open-end classification. What it is called as open-end classification. Why? Because here we don't know what is less than 10. It can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, anything. This end is open. That's the reason it is open-end classification. Nice name, right? Open-end classification. It's an inclusive data. Let's convert it into exclusive data before solving. Chalo. Let's convert to exclusive. Less than 10 will be less than 10 itself. All the values I'll reduce 0.5, 9.5, 19.5, 29.5, 39.5, 49.5. For all the higher values, I'll add 0.5, 19.5, 29.5, 39.5, 49.5, 59.5. Game over. Now, first quartile 3 I need to calculate. What the first step? First step is LCF. Chalo, let's do LCF. 5 plus 18, 23, I hope. Yes, sir, obviously this student. 23 plus 38, 61, 81, 90, 92. Obviously, sum of frequency will also be 92. Okay. So first step is LCF. What is the second step, my dear friends? Q3, right? Jn by 4. 3 into 92 by 4. 3 into 92 divided by 4. 69. Third, locate in LCF. Do you have 69 in LCF by chance? Anywhere is there 69 in LCF? No, sir, there is no 69 in LCF. If there is no 69 in LCF, what you will do? You will go for next higher value. 70 is there. 71 is there. Like that. 71, 72, 73, 74. What is the next highest value? 81. So, my dear friends, this is your Q3 class. What class? Q3 class. Locate in LCF, I located. Now I'll apply one jumbo formula. L plus Jn by 4 minus cumulative frequency of previous class, frequency of same class into class interval. What is L? 29.5. Jn by 4, 69. Cumulative frequency of previous class, 61. Frequency of same class, 20. Class interval, how will you get? Upper class boundary minus lower class. 39.5 minus 29.5. 10. 0, 0 cancel. So 29.5 plus 8 by 2, 4. That is nothing but 33.5. So what is quartile 3, my dear friends? Quartile 3 is 33.5. I hope it was simple to compute quartile 3. Okay. Now, let me compute percentile 65 for the same data. For the same data, I'll compute percentile 65. So that I'll give you one question which you people will solve now. So if any issue is there, see in this concept. It should be clear. Percentile 65. What is the first step? LCF, sir. Is it done? Yes, sir, it is done. What is the second step? I need to calculate JN by 100. 65 into 92 by 100. 65 into 92 whole divided by 100. 59.8. Third step, locate. There the hell is 59.8. There is no 59.8 only. So I will go for next higher. So this is your P65 class. Locate the class. Now what is the fourth step, my dear friends? L plus Jn by 100 minus cumulative frequency of previous class divided by frequency of same class into class interval. L, lower class boundary is 19.5. Jn by 100, 59.8. Cumulative frequency of previous class, 23. Frequency of same class, 38. Class interval is 10. So 19.5 plus 59.8 minus 23 into 10 whole divided by 38. That is 9.684. Which is 29.184. Okay. This is how you will calculate P65. Okay. Now do one thing. Digest the concept and I'll give you 3 minutes time. Go ahead and calculate quartile 2 and tell. I'll wait. Please calculate quartile 2. Okay, let's solve this sum. Quartile 2. First step is LCF. LCF is completed. Second step, n by 2. 92 divided by 2. We have 46. Next, third step, you locate the class. Where is the class here? 46. Again, sir, this is the same class. This is the quartile 2 class. Though quartile 2 is not asking, but we are doing. Okay. Next, locate class. Now you will apply the formula L plus n by 2 minus CF whole divided by F into class interval. So L 19.5 plus 46, cumulative frequency of previous class 23, frequency of same class 38 into class interval 10. Let's check. 46 minus 23 whole divided by 38 into 10. So 19.5 plus 6.05. So it is 25.5. Okay. So I hope you got the same answer. Yeah, you all got the same answer, lucky people. So I hope you are very happy that you got the same answer. Okay, fine, perfect. Now, I'll give you one question as homework. Think, solve, and get it. Okay. This is your homework. Okay. I know you will do wrong, but still, let me give it as homework. Observations. Instead of observations, data is given and values are given. Data is given as below 5, below 10. Just write it down the question. Note down the question. Below 15, below 20, below 25, and below 30. This is the data. Values are given 10, 25, 45, 55, 62, and 65. What I want you to compute here? I want you people to compute first median, second mode. This is your home. I guess here I wrote JN by 2. Yeah, quartile 2 and median both are same, right? So even if I applied n by 2 also, you will get the same answer because quartile 2 and median is same. So this is the homework, today's homework. Please note it down. You have to compute median and mode for this continuous data. Before coming to tomorrow's session, please make sure that you will complete. This is not a 110, this is 10. Once, just text me once you are done writing. I'll post it in the group also, so that if you are missed writing, you can take it from there. So I've posted it in the group. You can write it from there. Now, fine, sir. We understood individual data. We understood continuous data. Sir, then what about discrete data, sir? See, I'll take an example of discrete data. See, discrete data is not that important for examination. You will not find any examples even in ICA material also for the discrete data. Okay. So just one small question we'll see and we'll wind up discrete data. Now, observations are given. Frequency is given. Observations are given as 10, 20, 30, 40, 50, 60, 70. Frequency is given as 5, 7, 15, 12, 8, 13, 10. Now, since we are doing partition values, we are supposed to calculate LCF. 5, 5 plus 7, 12, 12 plus 15, 27, 39, 47, 60, 70. So total is 70. Okay, I hope total is 70 correct on. Let's check. 5 plus 7 plus 15 plus 12 plus 8 plus 13 plus 10. Yes, total is 7. Now see here how to calculate. First, let me calculate median. See if it is discrete data, how will you solve? It's not important if you don't remember also, it's fine. First step is LCF. You calculated LCF. Second step is you will apply individual data formula. Individual data, I didn't give any formula for median, but if you want individual data formula, you can apply like this, n plus 1 by 2. So from there you got, what is quartile 2 formula? J into n plus 1 by 4, right? J is 2 into n plus 1 by 4. 2 ones, 2 twos. So n plus 1 by 2. This is how I got quartile 2 and median both will be same, right? Even if you take decile 50 and percentile 50 also, you will get n plus 1 by 2 only. Okay. Now, n is summation of f. So 70 plus 1 by 2. 71 by 2, that is 35.5. This you will go ahead and you locate in LCF. If you locate in LCF, where you will have 35.5, you will have somewhere around here. That if that value is not there, we'll go for next higher value. Its respective observation, median is equals to 40. See, simple. First, you will do LCF. After that, you will apply individual data formula. First, do LCF, then apply individual data formula. After applying individual data formula, you will locate it in LCF. It's a respective observation will be the answer. Okay, let me give you a few more examples. Quartile 1, J into n plus 1 by 4. 1 into 70 plus 1 by 4. 71 by 4. 17.75. You shall locate in LCF. Locate in LCF. So 17.5. Where we have 17.5? 17.5 is not there, sir. go for next observation, which is 30. So quartile 1 is 30. Okay. Next, decile 7, j into n plus 1 by 10. 7 into 70 plus 1 by 10. That is 70 into 7.1. So 7 into 7.1, which is 49.7. This 49.7 you locate in LCF. 49.7. Respective observation, D7 is equals to 60. Okay. So I hope it is clear. Solve this percentile 74 and tell me. I'll wait for 1 minute. Percentile 74. Perfect. What about you, Geeta? Vaishnavi has given the answer. P74, j into n plus 1 by 100. 74. Perfect. Let me check. 70 plus 1 by 100. 74 into 71 divided by 100. 52.54. Locate in LCF. So this is where you will have 52.54. So P74 is equals to 60. Okay. So my dear friends, with this entire central tendency, types of central tendencies over. Okay. 2-3 additional points are there. We'll discuss it and we'll wind up the chapter. Now, to see here, I guess I wrote, discrete data. Apply individual data formulas and locate in LCF. You'll get the answer. Locate in LCF. It's respective observation is party value, not party value, party origin. I hope you remember this rules. Me, ye, मेरा दोस्त और ये party हो रही है, party हो रही है. Now see here everybody. Other points in median. What are the 2 other points? What we have? Median will be used in qualitative data. If you have any types of qualitative data, there you will go ahead and you will be using median. Right? Right? We know where to use AM, GM, HM, where you will use mode, fashion items, or zoology. In the same way, where you will use median, qualitative data. Now, before discussing this point number 2, there is one point what we have left in mean, right? We'll go ahead and we'll discuss that. And then we will discuss this point number 2. You will understand more clearly. ये मेरा दोस्त और ये पारी हो रही है. Like now, Cheem Tapaka Tum Tum is famous. Those days, this was famous. Like trend keeps on changing. Like our CA foundation exams were earlier 2 times. Now it became 3 times. Result came 5-6 days back. Then suddenly September exam is coming. Only 35 days after. It's a new trend. So let's solve point number 2. He is telling the sum of squared deviations from arithmetic mean are always given. I said you already what is deviation. Deviation means difference. So sum of deviations from arithmetic mean are always equals to 0. You have understood that. How will you calculate this deviation? Deviation will be x minus x bar. This is how you will calculate deviation. Okay. Now he's telling sum of squared deviations from arithmetic mean are minimum. Okay. Let me take an example. I'm having an example like this 3. Let's take a good example. What example? Let's take. Let's take 16 and 36. You want to take one more number? No, it's enough. 16 and 36. Now, what is the arithmetic mean of 16 and 36? Arithmetic means are simple. 16 plus 36 whole divided by 2. 26. What is geometric mean? Root of 16 into 36. 16 into 36 under root, just 24. Then what is harmonic mean? Harmonic mean 2 into I hope harmonic mean is 22.15. Now see here what is telling. Sum of squared deviation from arithmetic mean. First, sum of squared deviation. This is squared deviation. This is squared deviation from geometric mean. This is squared deviation from harmonic mean. Understand what is telling. Squared deviations from arithmetic mean, squared deviation from geometric mean, squared deviation from harmonic. Squared deviation from AM, squared deviation from GM, squared deviation from HM. Now, first squared deviation from AM. X minus x bar. 16 minus 26. Minus 10 square. Next, 36 minus 26. Plus 10 square. 100. 100. 200. Square deviations from arithmetic mean is 200. Now square deviation from geometric mean. 16 minus 24. Minus 8. Next 36 minus 24. 12 square. 144. 208. Next. Square deviation from harmonic mean. We have 16 minus 22.15 minus 6.15 whole square. Next, 36 minus 22.15, 13.85 whole square. That is 7.8225. 191.8225. Which is 229.645. Now think and tell me, I have calculated square deviations of observations from arithmetic mean. I have calculated square deviation of observations from geometric mean. I have calculated square deviations of observations. I have calculated square deviations of observations from arithmetic mean. I have calculated square deviations of observations from geometric mean. I have calculated square deviations of observations from harmonic mean. From these three, where you find the least answer? Obviously, sir, the least answer is here, right? Let's keep one more thing. The least answer is here, right? That's what I said. Sum of squared deviations from arithmetic mean are always minimum. Okay. So I hope point number 2 is clear. Shall we proceed further? Yes, thumbs up, thumbs down. You can give reactions instead of typing. You can use reaction button. Like I have given reaction button. Yeah, fine, thumbs up. Now I have raised the hand. I've lowered the hand. Can give reactions also, that's fine. Okay, so I hope you have Understood? Sum of square deviations from arithmetic mean are minimum. Chalo, let's proceed further. Now let's come to this point. Yeah. See here, absolute deviations are always minimum taken from median. Deviation, we know, difference is called as deviation. Now, what the hell is this absolute deviation? Absolute deviation means differences where negative signs are ignored. Those are called as absolute deviations. Like say, for example, I'm having 3 observations, 1, 5, 7. What is median here? 5. Now, what will be the absolute deviations from median? Modulus of x minus median. Why I have taken modulus? Because you are ignoring negative signs. 1 minus 5. I'll write 4. I'll not write minus 4. 5 minus 5, 0. 7 minus 5, 2. Which is equal to 6. That's what I'm telling. Sum of deviations from absolute deviations. So absolute deviations are always minimum from median. Now here, instead of median, you keep mean, you keep mode. The value will always be equal to 6 or greater than 6. But it will never be less than 6. That's what I'm saying. The sum of absolute deviations taken from median are always minimum. Now, what are absolute deviations? Deviations where negative signs are ignored. Where you ignore negative signs, those are called as absolute deviations. So I hope the concept is clear. Yes, the point is clear. Now, let's proceed to the next one. So, central tendency is completed. There is one thing what you need to know. Relationship between mean, median and mode. First is if all observations are same, mean, median, mode, everything will remain same. Next, in case of normal distribution or perfectly skewed data, this normal distribution we'll learn in theoretical distribution. In case of normal distribution, mean, median, mode, all the 3 will remain same. Perfectly skewed data means if the data looks somewhat like this. It looks like curve, bell-shaped curve. X bar will be equals to median is equals to mode. Next, in case of positive skewed data, you need to just remember the terminology because skewness we don't have in the syllabus. Earlier, we used to have it in the syllabus. In case of positively skewed data, like say, for example, I'm telling marks obtained in toughest examination. You know, in toughest examination, most of the people will get less marks. That is the reason more clutter is there towards less marks. In case of positively skewed data, mean is greater than median is greater than mode. In case of negatively skewed data, more people will get highest marks. That is, clutter is towards the highest marks. Mean is less than, median is less than. In case of positive data, this symbol. In case of negative data, this symbol. Okay. Next, empirical relationship given by Carl Pearson for an asymmetric distribution. Now, what is this empirical distribution? Empirical relationship means this is not any correct relationship. Okay. Using past, crores of figures, you will develop a regression equation. Using that, you will calculate relationship. That is called as empirical relationship. See, this empirical relationship will give only approximate answer. It will not give you exact answer. Because there is no proof for empirical relationship what exists. Okay, without proof, if you develop a relationship, that is called as empirical relationship. Empirical relationship will be mode is equals to 3 median minus 2 mean. Like say, for example, I am saying median is equals to 30. Mean is equals to, median is 30. Mean is equals to 25. What is mode? 3 into 30 minus 2 into 25. 90 minus 50. So mode will be equals to 40. Okay. There are 3 formulas. All 3 formulas are same. Like if you subtract mean on both sides, it will be mode minus mean. is equals to 3 into median minus 3 into mean. I took 3 common. So subtract minus on both sides. Mean minus mode is equals to 3 into mean minus median. Sir, why you have given this? Sometimes in examination, he'll tell you mode minus mean is equal to 60. What is median minus mean? He'll ask. See, this type of nonsense questions he'll ask sometimes in the exams. That's the reason I'll be using this. We know mode minus mean is equals to 3 into median minus mean. 60 is equals to 3x. 20 is equals to x. Okay. Since sampling theory is introduced in the syllabus, remember this one small point. Mean has sampling stability. I'll explain this when I explain you sampling theory. Not now, I'll explain it when I explain you sampling. Fine, everybody. That's all regarding central tendency. We are done with central tendency chapter. Simple chapter. Okay. Now, let's continue with measures of dispersion. Now, what is this measures of dispersion? In central tendency, we have calculated the mid value, right? Which tells you about the data. In dispersion, we will calculate deviation or spread from the central tendency value. To calculate deviation or spread from the central tendency value, we call it dispersion. Like say, for example, I have calculated average, that is mean. Average came to 75 marks. Okay. In a class, I calculated average came to 75 marks. I'm having 3 students, student 1, student 2, student 3. Okay. Now, if you see marks scored by them, student 1 scored marks of 60, student 2 scored marks of 73, student 3 scored marks of 83. What can you comment on these people? I can say 1 is poor student by 15 marks. Best student by 8 marks. Normal student by 2 marks, right? So what you are doing, you are calculating deviation of observations from central tendency value. To calculate deviation of observations from central tendency value, we call it as dispersion. Like say for example, you have written examination. You got 56 marks. Okay. In your house, they started scolding you. And you said, parents, mom, dad, you are sad that I got 56 marks, but the average marks of the entire school is only 52. So please don't scold me. I got 4 marks more than average. This is what you are describing yourself when compared to average is called as dispersion. The deviation of observations from central tendency value is called as dispersion. Now, what is one more name? It is also called as average of second order or measures of deviation or measures of spread. Okay, these are other words. Like I said, central tendency is first order. Okay, central tendency is first order, dispersion is second order, right? Skewness is third order, kurtosis is fourth order in this manner. Next. Now, types of dispersion. Now, how many types of dispersion you have? You have 2 types of dispersion, absolute measures of dispersion and relative measures of dispersion. Now, see, if you want to calculate relative measures of dispersion, we require absolute measures of dispersion. Without absolute measures of dispersion, unfortunately, you can't calculate relative measures of dispersion. First, calculate absolute measures of dispersion, then use them to calculate relative measures of dispersion. Now, what are absolute measures of dispersion? If you calculate the dispersion in units, That is called as absolute measure of dispersion. Like see here what I have done. I calculated the dispersion 15 marks, 2 marks, 8 marks, right? Instead of calculating the dispersion in units, that is called as absolute measure. If I calculate the dispersion in percentage or number or degree, that is called as relative measure. Remember, my dear friends, in statistics, percentage, number, degree, all the three things are same. They are used alternatively or they are used interchangeably. Okay. Relative word is also called as percentage, also called as number, also called as degree. Okay. In absolute measures, you are calculating dispersion in units. In relative measures, you calculate dispersion in percentages. Now, comparison between similar units is possible, but comparison between different units is not possible. Here, there is no restriction on comparison. Let me give you an example. Now, example, I am having two students, G and V. Okay. G scored marks 80 marks. V scored marks 75 marks. Okay. When G and V went to their parents started scolding V. Useless V. You got only 75 marks. What nonsense person you are. All those things started scolding. But when you see total marks, G got 80 for 200 marks. V got 75 for 100 marks. So if I calculate percentage, it's 40% and it is 75%. So can you see what's happening here? Units are misleading. They have misleaded the parents. Unnecessarily, we got beatings. But in reality, G got very less marks. We got very high marks. Okay. So this units are somewhat misleading. But percentages are never misleading, my dear friends. Okay. So be careful. That's the reason I said comparison between similar units is possible, but comparison between different units is not possible. One is in kg, one is in kilometer. How will you compare? Nonsense. But both are in percentages. Can you compare? Yes. Next. How many types we have? 4 types of relative measures, 4 types of absolute measures. Range, quartile deviation, mean deviation, standard deviation. Coefficient of range, coefficient of quartile deviation, coefficient of mean deviation, coefficient of standard deviation. So 4 relative measures, 4 percentage measures. Now, in question, he'll ask you degree of variation. Where you will calculate degree of variation? Where you have seen the word degree? Here we have seen the word degree. Degree of change is calculated in relative measure. Next, amount of variation is calculated in absolute measure. Now, this range and quartile deviation, what is there? They are positional measures. Mean deviation, standard deviation, they are algebraic measures. You already know what a positional and algebraic measure. Algebraic measure means all the observations are taken into consideration. Positional measure means only few observations are taken into consideration. What is the standard deviation, my dear friends? The standard deviation is best method. If you see in foreign countries or if you see any foreign courses, dispersion means they'll not teach you range, quartile deviation, mean deviation. They'll just teach you standard deviation. I hope that's fine. Standard deviation is best. Now let's start with range. Once range is completed, we'll wind up. Don't worry. I know dispersion, right? It will go a little heavy. Now, range. In range, what we are calculating? We calculate the difference between largest observation and smallest observation. Let it be individual data, discrete data, or continuous data. Formula is same. Okay. For range, frequencies are of no use. Let me take an example. I am having 10 rupees, 20 rupees, 40 rupees, and 60 rupees. What is the range, my dear friends? Range is largest observation minus smallest observation. It is 50 rupees. Now in the options, You will have 50 rupees, 50 percentage, none. Be careful. Range is absolute measure. So you will write it in units. Now I'm telling coefficient of range. Highest observation minus lowest observation divided by highest plus lowest into 100. So 40 divided by 60 into 100. So this is equals to 66.67%. Okay, coefficient of range is 66.67%. So this is how you calculate for individual data. Now let's take discrete data and continuous data. Example. Observations you have, frequency you have. Observations are 10, 20, 30, 40. Frequency is 7, 5, G, V, K. Okay. Now what is the range? Same. Highest observation minus lowest observation. Let us take this as kgs, which is equals to 30 kgs. Did I use frequencies to calculate range? No, my dear friends. That's the reason I said for range, frequencies of distribution are of no use. Let it be individual, discrete or continuous, everywhere range formula is same, L minus S. Now coefficient of range, 40 minus 10 by 40 plus 10 into 100. So 30 by 50 into 100, which is equals to 60%. Okay. So range is done, coefficient of range is done. Now, let us do continuous data. Observations are in meters and frequency. 30 to 40, 40 to 50, 50 to 60, 60 to 70. G, V, K, 70. So range will be highest observation minus lowest observation, which is equals to 40. Okay. Coefficient, highest minus lowest divided by highest plus lowest into 100. So 40 by 100 into 100, which is equals to 40%. Okay. So I hope that's fine, everybody. Range, coefficient of range, all those things. Now, I'll stop it here because it's a discussion, right? It will go a little heavy. So in tomorrow's session, we'll complete the discussion part. Okay.